So this is the second video for your chapter review, filling in the questions that were not covered on the first video. So we're on number 14. Already got it written down here. Just some basic cross multiplying here. So 6 times 5 is 30. And when you cross multiply the other direction, you have to distribute. So it's 2 times y minus 4. So we're going to go ahead and distribute that. That's 2y minus 8. And then you just solve it like normal. But we want to get y by itself, so I'm going to go ahead and add 8 to both sides. So 2y equals 38, and you divide by 2, and y equals 19. Jumping to 16. So it looks a little goofy because we've got just a whole number 4 on the right side, but we're going to put it over 1, and we're going to cross multiply. So it's 4 times a minus 3, and it's 1 times, if you want to write it out, you can write it out, a plus 12, but anything times 1 is just going to be itself. So it's just a plus 12. Over here, though, we do need to distribute, so it's 4a minus 12. A on both sides, minus the smaller. So it is 3a minus 12 equals 12. We're going to add 12 to get rid of this minus 12. Divide by 3. And a equals 8. All right, we are going all the way to number 28. Working on some conversions here. So during a meteor shower, some meteors approach Earth's atmosphere at speeds of 95 kilometers per second. So 95 kilometers for 1 second. Using the fact that 1 mile is 1.6 kilometers, convert this rate into miles per hour. So we've got to go from seconds to hours and kilometers to miles. Let's start with the kilometers because that's what they gave us right here. Of course, you put kilometers on the bottom, so miles must go up top. Drop the numbers in. 1 mile, 1.6 kilometers. Now we have to go from seconds to hours. Let's do that in 2 steps. Instead of trying to figure out how many seconds are in an hour, let's throw seconds up top and cancel it out and go from seconds to minutes. We know there's 60 seconds in 1 minute. And then that will leave us minutes. So seconds have canceled, kilometers have canceled. If we left it like this, we'd have miles per minute. Now we're going to go and cancel minutes out and turn that into hours. So we know there's 60 minutes in 1 hour. Minutes cancel. If we run the numbers now, looking at the units, miles on top, hours on the bottom, that's what they want. So we just need to go ahead and run these numbers right here. So straight across the top with your calculator, you end up with 342,000. On the bottom, that's all ones except the 1.6. And again, miles on top, hours on the bottom. So if we go ahead and simplify these by dividing, 342,000 divided by 1.6, we get 213,750 miles per hour. All right, 29. The average human adult at rest takes 16 breaths per minute. So 16 breaths per minute means 1 minute. So letter A. How many breaths would a human take in a week? So we're going to leave breaths. We're not changing that, but we have to go from minutes to weeks. So let's first go from minutes to hours. So minutes up top, hours on the bottom, 60 minutes in 1 hour. Once we're in hours, let's go to days. Hours up top, days on the bottom. How many hours in a day? 24 hours in 1 day. And now let's go days to weeks. 7 days, 1 week. So you notice on the bottom, it's all ones. So we're going from 16 breaths to per minute, And we're going to go to an hour by multiplying by 60. Multiply by 24 to get a day, multiply by 7. So let's run this across here. 16 times 60 times 24 times 7. Total of 161,280. And that's breaths per week. Letter B. If a cat takes 1,500 breaths per hour, does the cat or human breathe at a faster rate? Two ways to do this. You can go ahead and take this one per hour and get it all the way to a week and compare it to this one. Or we can go back and just compute this little section right here. Because if we stop right here, minutes cancel out and we have breaths per hour. And we can go ahead and compare. So 16 times 60. That's 960 breaths. The minutes canceled per hour. So right there you can obviously see who is breathing at a faster rate. The cat. All right, we are jumping to number 36. A pair of shoes originally cost $53. It's on sale for $42.40. What's the discount rate? What's the percent that you got off? So first of all, we need to find out how much you got off. So 53 minus 42.40. You got $10.60 off the price. That's the number we need to compare to the original. This is how much came off the price. We want to calculate what percent is that. So you're going to divide 1060 by 53. That tells you what part is it, what percent is it. So 1060 divided by 53. You end up with 0.2, which you translate to a percent, and that is 20%. Letter B, find the total amount saved including tax if the tax rate is 6.25%. So originally you were going to pay $53 and they were going to tack on 6.25% to that. So what we can do is we can multiply that by 1.0625, or you can just multiply this by the percent, 0.0625, and add that on. So 53 times 0.0625. And when you get that number, you can't see it on my phone, when you get that number, it's $3.31, but there's a 25 at the end of it. You add that to 53, and you round it off. We would have ended up with $56.31. Now, with the new price, $42.40, the 0.0625 of that is going to be less. Okay, the tax on $42 is less than the tax on $53. So we need to calculate what's the tax, add it on. How much would this cost with the tax, and then compare it and find out how much we would save. So 42.40 times 0.0625 is $2.65. You're going to add that to the 42.40 to find out what was the total cost, so $45.05. So after tax, this is how much it would have cost in both scenarios. Original cost plus tax, new cost plus tax. So how much did you save? That's what they're asking here. So you're going to go ahead and just subtract those. 56.31 minus 45.05 comes out to $11.26. You'll notice that it's at $11.27 in the review packet, and that is because over here we did have more numbers past the 31. And even though mathematically we only round up when it's 5 or higher, when we are talking about money, if something is above a certain amount, they're always going to round it up for you, right? They're not going to let you save money. Even if it's a partial cent, they're always going to round it up. And so the book rounded that one up. I left it alone because mathematically we only round up when it's 5 or higher, but it is good to understand why they did what they did. All right, we're going to number 37. Okay, on 37, we're going to make a certain shade of green paint. We're going to mix 5 parts blue and 3 parts yellow. That's going to come out to a total of 20 gallons. So our total number of parts is 8. You add that together. And we're going to take our 20 gallons and split it into 8 parts. So we need to divide and find out how much one part is. And then once we know how much one part is, we can designate it to the 3 parts and the 5 parts. So we need to do 20 divided by 8. And that's 2.5. So one part is 2.5. Let's answer the question. How many gallons of each paint? Okay, so we got to go back to both of them. So we need 5 times, so plug in the P, 2.5. We need 3 times 2.5. So we get 12.5 right here, and that is, what's our 5P? Blue paint. And 3 times 2.5 is 7.5, and that was yellow. Okay, number 40. All right, now we're going on to some probability here. Number is selected randomly from the integers from -1, 0, 1, and then the dot, dot, dot means they're counting from 1 all the way up to 8. So integers are whole numbers, 2, 3, 4, 5, 6, 7, 8. What's the probability that the number is greater than 1? So -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So when you calculate probability, it's going to be something out of 10. There are a total number of 10. And we're calculating what's the probability that the number is greater than 1. So these 3 are not greater than 1. So 1, 2, 3, 4, 5, 6, 7. It is going to be 7 out of 10. If you divided that, you'd get 0.7, and you could turn that to 70%. Both of these say the same thing, 7 out of 10, 70%. It's good to be able to understand both of those. All right, 41. A fair die is thrown once. So a die has 1 through 6. Find the probability of getting an even number greater than 2. So on a dice, you can get a 1, a 2, a 3, a 4, a 5, a 6. So our total number of outcomes is 6. How many even numbers are there greater than 2? So 4 and 6. That's a 2 out of 6 chance. And if we go ahead and we simplify that, divide by 2, that is a 1 out of 3 chance. 42. The probability of winning a raffle is 1 out of 25,000. What's the probability of not winning? So that is all the other outcomes. That is called complementary. You have a 1 out of 25,000. So all of the other outcomes, 1 out of the 25,000 is in your favor. All of the other outcomes are not. So that is 24,999 out of 25,000. All right. 47. I'm going to start moving this over here. Got a lot of work to do on number 47. We're looking at this target right here. So they go ahead and explain it, but you can see it all in the picture. All right, so all the points inside the square are likely to be hit. Now, one thing you do need to notice in this picture is that this largest circle has a radius of 16. And so that radius of 16 is all the way around, including where it hits the edge of the square. So it's a little tricky because they don't give you the sides of the square here. But from the middle down is 16, which means the other direction is also 16. So the side of the square from the middle down is 16. From the middle up is 16. So this whole side is 32. All right, so this square is 32 by 32. So the square's area, base times height, is 32 times 32. We're going to need that. That's our total number of outcomes here. The entire board has an area of 32 by 32, which is 1,024. So the person with the bow and arrow randomly shoots at the target so that all points inside the square, not the circle, the square, are likely to be hit. What's the probability that it hits the bullseye? So our total area is 1,024. We're going to compare the area of the bullseye to that. So the bullseye pi r squared. We're going to plug in for r, which is 4, 4 squared, which is 16, and we're going to leave pi alone, so 16 pi. So if we're going to go ahead and we're going to find the probability here, it is going to be 16 pi over 1024. Now you could go ahead and divide that and figure that out. Okay, but you can also simplify this, and 16 over 1024, if you plug that in your calculator, those both divide by 16, and you end up with a 1 over 64. So again, 16, ABC button, 1024, or 16 fraction 1024. You plug that in your calculator, it will simplify that fraction for you to 1 over 64, and pi does tag along. And so we don't need the 1 in front of pi, and you'll see the answer in the book is just pi over 64. That was part A. Part B, what's the probability that the arrow hits within one of the two middle rings, but not within the bullseye? Okay, so now we got a lot of work to do. We have to find the area of all of these circles, basically, or at least these three. Or if we find the area of this medium circle and we cut out the area of this little bullseye in the middle, that'll be these two rings. That's what we need. So first thing we should do is find the area of these two rings, this circle, including everything. So that would be the radius of 12. So it's pi r squared, which is pi times 12 squared, which is 144 pi. 12 squared is 144. And what we're going to do is we're going to go ahead and subtract the bullseye out. And we already know the bullseye is 16 pi. So we're going to take 144 and we're going to minus 16. So 144 minus 16, that's 138 pi. Perfect. All right, so 138 pi. That's the area of these two rings here, the blue and the green, with this cut out of it. So we found the area of this whole circle, not the biggest circle, but the one with the radius of 12. That includes that bullseye, and then we subtracted the bullseye out. So we have a 138 pi. What's the probability that the arrow hits within one of the two middle rings? Okay, so we're going to compare that area, which we figured out is 138 pi, to our total of 1024. So we can go ahead and plug that in. $138 divided by 1024. Because 144 minus 16 is now 138. Maybe you caught that. It's 128. All right, let's try that again. 128. Simplify. There we go. Okay, so if you plug in 128 over 1024, that will simplify to 1 over 8. Pi tags along. Final answer is just pi over 8. Now, when we get to the quiz, it won't be that complicated. We'll make sure these things simplify nicely for you, but let the calculator do the work. Plug that in with your fraction key, ABC button, or however your calculator, depending if you have a scientific or graphing, simplifies fractions. Let the calculator do the work for you. All right, that was 47. We're just doing 57 and 58, and we are all set here. All right, 57. We got this picture here. We've got similar shapes. This one has x4 and 9. They're sitting the same way, so I can just match them up based on how they're sitting, which is nice. So 32, 6, and y. So first, give two possible ratios of similitude. That's a fancy way to ask the question. So all you got to do is match up the corresponding sides. You could say x over 6 because those match. You could say 9 over 32 because those match. Or you could say 4 over y because those match. You could also go the other direction and say 6 over x, or 32 over 9, or y over 4. Those are all fine. All right, letter B, solve for y. So when you have these ratios of similitude, that fancy word, what you do is you set them equal to each other and cross multiply, and you can solve for missing pieces. So the only way that works, though, is if one of your ratios has two numbers, like 9 over 32, and you set that equal to the one that you're trying to solve for. So on letter B, they want us to solve for y. So I'm going to set this up right here, 9 over 32 equals 4 over y, and then I'm going to cross multiply. So I get 9y equals, I got to do 32 times 4, 32 times 4, over 128, and then I divide by 9. And that gets me 14.2 repeated. So instead of writing 14.2 repeated, I'm just going to leave my answer here, because the y's cancel, as 128 over 9. And that's what you'll see on the answer key. And then letter C, solve for x. So now I'm going to set these up. I'm going to use the 9 over 32 again. And it doesn't matter which side of the equal sign you put them on. And then the x over 6. Cross multiply, so I get 32x. And 9 times 6. So 54 divided by 32. Now that doesn't divide nicely either, though it's okay. 1.6875, and we're okay with that. Otherwise, you leave it as a fraction, but it does simplify by 2, and so if you simplify this in your calculator, 54 over 32, that's what you're going to see on the answer key. If you divide both of those by 2, you get 27 over 16, and that's as far as it's simplified, but I do like that decimal. It's full, it doesn't need to be rounded, and so we're going to go ahead and run with that decimal as well.